Hi, this is Mrs. Rodriguez with another lesson video. Today we're looking at similar figures or scale drawings. So, what are similar figures or scale drawings? Well, that's when every length of the figure or drawing is made larger or smaller by multiplying all the sides by the same number, or constant of proportionality, which we're going to call the scale factor. Now, if constant proportionality sounds familiar, it's because this is basically the unit rate for scales and drawings, okay? So scale factor is the unit rate. Just like we call the unit rate constant of proportionality, well, the scale factor is the unit rate for similar figures and scale drawings, okay? And when we say every length of the drawing is made larger or smaller, think of a copy machine. On a copy machine, you can blow up a picture to make it bigger, or you can shrink a picture to make it smaller. So that's what we're looking at. Images that have been made bigger or made smaller, but doesn't change the shape, right? Okay. Of course, if it has a constant proportionality or scale factor / unit rate, then it is proportional, okay? The scale factor is that number, that same number that all the sides are multiplied by to make the image larger or smaller. Okay, so once again, if the scale factor has to work with all sides, just like the unit rate had to work with all the x's and y pairs, the scale factor has to work with all the sides for it to be proportional. And lastly, there is no distortion of the image. All parts of the new image are proportional. Shapes stay the same and are just a larger or smaller version of the original image, okay? So there's no distortion. Same exact image, just bigger or smaller. So let's take a look at a couple of examples of similar figures or scale drawings. The first painting we see for A, and then B is that same exact painting just made larger. Notice all the proportions within the painting, all the shapes stay the same. Okay? And for B, you can think of, for the second example, you can think of A like the original fingerprint and B like we took that fingerprint and we blew it up to make it bigger, maybe, you know, like the police do to check the fingerprints to make sure they match or to see if they match other fingerprints. So it's the exact same fingerprint, just made bigger. So then you might be asking, well, what do you mean no distortion of the image? Well, let's look at an example. Here we have examples of non-proportional figures or drawings. So this is distortion. We have our original picture of this boy. You will notice in A, it's not the same image, okay? It's been stretched out. So they multiplied the length so that it would stretch out lengthwise, but they never multiplied the width. And what happens is instead of getting the exact same image that's proportional and bigger, now the shape has changed because they didn't multiply all the sides by the same number. They didn't multiply by a scale factor that worked with all the sides. And then if you look at B, it's the opposite. Instead of stretching it, they widened it. But once again, not everything was multiplied by the same number. Not all the sides in the image were multiplied by the same number. So there's no scale factor. And as a result, it looks like they just multiplied the width, but not the height. So we end up with this squished figure. And you'll notice the boy's head shape's not the same. The body shape is not the same. He looks shorter and wide. In A, the shape's not the same. Now his head is elongated. It's just not proportional, okay? And these are what we call distortion, right? Here we go. Now, before we continue, there's a couple of vocabulary words that I want to go over. And the first one is enlargement. Enlargement means to make bigger, and a really good hint to memorizing or remembering that enlargement means bigger is that it has the word, it has the word large in it. Okay, so enlargement, to make bigger. Reduction is to make smaller. Okay, so reduction means to make smaller. Reduction, to reduce. Okay, so let's take a look at a couple of examples. In the first example, we have a trailer. We have the actual trailer and the scale drawing. So the actual trailer is bigger than the drawing, so that means it was made smaller. So that's reduction. That's an example of reduction. When you take something and make it smaller. All right, now here's another example. We have an actual picture of a watch and then a scale drawing of the watch. Notice the scale drawing's bigger than the original picture. So this would be an example of enlargement. Okay, enlargement. All right, so now we're ready to look at how to calculate scale factor. So the formula for scale factor is new over original. New over original. So let's take a look at our first example. Celeste drew an outline of a building for a diagram she was making, and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table below, and fill in the table. So let's go ahead and take a look. In the first building, the width, we're going to be looking at the height and the length. Okay, so let's look at the height first. So in order to see how tall it is, we have to count how many boxes are this height. So that's 2 away from 20, so that would be 18. Or you could just count the boxes, you'll get 18 again. The length, or the width, is from this point to this point. So if I counted the boxes, it would be 1, it would be 1, 2, 3, 4, 5, 6. So from here to here, it's 6. Okay, so the length is 6. Now for the second drawing, okay, now remember, this is the original, and then she made a second drawing. So this is the new. The height now is there, which is 9. And the length, or the width, 1, 2, 3, is 3. Okay, so we have the original and we have the second drawing. Does a scale factor exist? If yes, what is the scale factor? So remember, the scale factor equals new over original. So we have to check, is there a scale factor? So for the height, the new drawing is 9, the original is 18. And I can simplify that because 9 goes into 9 and 9 goes into 18. We end up with 1 over 2. Now, if there is a scale factor, then it needs to work with the length as well. So let's go ahead and check the length. For the new length, it was 3, and for the original, it was 6. Okay, once again, we can simplify this. 3 goes into 3, and 3 goes into 6. 3 goes into 3 1 time, 3 goes into 6 2 times. So this is for the length. Did we get the same number? Yes. So yes, there is a scale factor. And what is it? It's equal to 1/2. Is Celeste's drawing an enlargement or a reduction of the original drawing? Well, the drawing got smaller, so that means it's a reduction. Are these two images proportional? Yes. There is a scale factor. Has scale factor equal to 1/2. So yeah, it's definitely proportional. All right. Let's take a look at a couple of more examples. Now, these are two examples side by side. I'm going to go ahead and draw a line going down to kind of separate them so we don't get confused. And let's take a look at the first one. In the first one, we have two rectangles, okay? And we've been given the sides of these rectangles. And here's the original, here's the new. All right. So we need to remember that scale factor, and I'm going to write SF because I don't want to have to keep writing scale factor. So the scale factor is new divided by original. Now, it doesn't matter which side you choose. Up here, I forgot to read the directions, but it says determine if each pair of figures are proportional, and if yes, calculate the scale factor. So we want to know, is it proportional? And if it is, what's the scale factor? Now, once again, it doesn't matter which sides you choose first, because you're going to have to check all the sides to make sure that every single side works to really know if it's proportional. So remember, all it takes is one side not to work to make it not proportional. So you have to make sure there's a scale factor and that it's the same number for all the sides. So I'm going to start with, I'm going to start with 6 and 3, okay? We have to pick corresponding sides. So if I'm picking this side in my original, corresponding sides means I have to pick that same side in my other drawing. All right, so we're going to check those first. New over original. Well, the new is 3, the original is 6. 3 goes into both, so we can simplify it to 1/2. Okay, so that's the scale factor for that side. Now, we can check this side of our rectangles, and if we get 1/2 again, that means yes, there is a scale factor because 1/2 worked for both sides. Okay, so scale factor. The new now is 4 and the original is 8. I can simplify this because 4 goes into both 4 and 8. 4 goes into 4 once, 4 goes into 8 twice. Did we get the same number for both? Yes. So this is definitely a yes, it's proportional, and the scale factor equals 1/2. Now let's check the second shape. Now in the second example. Now in the second example, once again, we have our original, we have the new. It doesn't matter which sides you start with, again, as long as they're corresponding, right? They're the same side for each image. Now, I would advise though, because here we have this 1 1/4, we're going to have to check all the sides to make sure that they're proportional, but we can choose what sides to start with. And I always recommend choose easier numbers first. That way, if there's an issue and you don't get the same scale factor, you catch it with easy numbers. But if you go through and do the easy numbers first and they all work, then you can save the hard one for last. All right, so let's go ahead and get started. I don't really want to mess with that 1 1/4, so instead, I'm going to start with this side. And if I do it on this right side for the first image, I got to do the same side in my second image. So that's going to be 1 and 4. So scale factor equals new over original. So that's going to be 1/4. We can't simplify that, so that's the scale factor for that side. If we keep getting 1/4, then we know, and it works for all the sides, then we know it's proportional. All right, let's go ahead and check another side. So once again, don't really want to deal with that 1 1/4 yet. So I'm going to check the bottom. Now we're going to check the bottom of both images and see if we get 1/4 again. So once again, scale factor equals new over original. And I recommend writing that each time you're going to solve for for the scale factor, because the more you write it, the easier it'll be the easier it will be to remember. So I like to keep writing the new divided by original, right? Okay, so for the bottom, the new was 2, the original is 7. Okay, well, 2 doesn't go into 7, and only 1 and 2 go into 2, so we can't simplify that one. So lo and behold, did we get the same number? No. Big no. So there's no scale factor. We got 2 different numbers. So it did not work. And you will notice I started with the easier numbers, and I didn't even have to get to this fraction here. So, I say go with the easier numbers first. If we would have gotten the same answer for both the right side and the bottom, then we would have had to check the top, the 5 and the 1 1/4. But it turns out the numbers didn't match for the right and the bottom, so we didn't have to go to the 1 1/4 and 5. Okay? All right, so that's how you calculate scale factor. Okay, remember, the big thing to remember is scale factor is new. Scale factor is new divided by original. Okay, it's a ratio. So you're going to take your 2 numbers, divide them, see what you get. Okay, and remember, you have to use corresponding sides. If you're doing the bottom, you have to do the bottom. If you're doing the right side, you have to do the right side on both images, right? Okay, and as always, if you have any questions or need additional assistance, feel free to make an appointment with me for office hours. Hope you have a great day. Bye.